Okay, good afternoon, everyone. My name is Uwe Beder. I'm from Rode and Schwarz, and it's our pleasure today to present a couple of modern test and measurement insights for the very fast-growing field of satellite communication, and here especially the type of satellite communication where you can make a connection to your mobile phone. That's called direct-to-cell, D2C. So let us start a little bit from the very beginning. When we are talking about satellite communication, usually you have a couple of interferences that might affect your network. These harmful interference can be classified basically in three different areas. One is intentional interference, which is also jamming, unintentional interference, and natural kind of interference. So intentional interference is really that you introduce signals in the satellite signal paths to decrease the quality or even break the communication link completely. Unintentional interface can come from erroneous devices who have more emissions than actually planned for, and this is usually all by unqualified operation. Natural kind of interference is, of course, any kind of disruption that you have which comes from natural sources, which are a problem because we cannot influence, they are not man-made. So here you see a coarse picture of satellite communication and the different passes. So on the one area you have the modem, you have the unit which brings the signal to the satellite, and from the satellite it's distributed to all different kinds of other stations. One could be a simple ground station, but the thing that makes now the differentiation is the mobile phone. And now imagine you are not having a mobile phone for a terrestrial network in your pocket. You would have all of a sudden a satellite terminal that you can carry around, and you can everywhere connect to a satellite constellation. Of course, you have a lot of these mobile phones. This adds a lot of interference in some areas, so you need to have a very controlled environment that these satellite links with a direct-to-cell are working correctly. So here you see a focus on when we talk about non-terrestrial networks, NTN. You have different types of networks, and usually you classify them as LEO, MEO, and GEO. LEO are the low Earth orbit constellations, usually in an altitude range between 300 and 1,500 kilometers. And the typical footprint of these beams is in the 100 kilometer area. We have the medium Earth orbit, which is between 7,000 and 25,000 kilometers altitude, and they have a slightly larger footprint, but can be in the same area. Then most of the communication happening via satellite today are so-called geostationary systems or geostationary Earth orbits. They are also used for broadcasting. What is the specific thing about this? The geostationary orbit has the same round-trip time like the Earth's rotation. So basically the satellite is always placed at the same position when you look from the Earth in the sky. And of course it makes only sense when it's located at the equator area. So this orbit is already filled up quite good because this has been a prominent spot for broadcast satellites, but also for Earth, also for communication satellites. When we talk about direct-to-cell is basically working with the low Earth orbit constellation. So here you have typically the satellites, as mentioned, up to 1,000 kilometers, And when you do some math, then you can see that a satellite needs, in that altitude, needs to have some speed that it doesn't fall back on Earth. So when you do the math, you come at a point that a satellite round trip around the Earth is around 90 minutes. Not 19, 90 minutes. And usually what you can also see from that, from a point when you are on the Earth, then you would have the satellite in your visible area roughly 2 minutes. So even if you don't move, then you need to do a handover. You know, the handover from one cell to another cell in the terrestrial networks. You need to do a handover every 2 minutes. So the first example where we find a regulation for this direct to cell, because you basically are using frequencies that are in the terrestrial area, is from the US. So the Federal Communication Commission, FCC, has done a regulation on supplemental coverage from space, and there are a couple of points which need to be fulfilled. An operator of this SCS service must have a spectrum lease from a terrestrial licenses. These SCS bands basically follow the mobile communication bands below 2 gigahertz. This is what you can see there. It ranges from 600, 700, 800 megahertz, but also in the below 2 gigahertz range. There are also maximum values for power on Earth, which is given as a power flux density. And you see we have basically two values, one for the bands below 1 gigahertz and one 47 dB microvolt per meter for the bands below 2 gigahertz. Certification of these devices don't need to follow a very special process, but they need to be recertified that they can be used for satellite communication. Also, an SCS operator has a requirement to have a public safety answering point defined, because you can imagine these systems of satellite communication makes a lot of sense in the rural area where you have no other means of a connection, and you want to make sure that emergency calls work. So here you see a first measurement that we have done in the US, where this, as said, this regulation is in place. What you see here on the screen is a power measurement on a time basis. And this has been done on the Starlink system. You know, the SpaceX system, Starlink, has already satellites in operation for direct to cell. So what you could see in the beginning, you have a group of 4 satellites which we can measure, and these 4 satellites come again in around 90 minutes, which is exactly the round trip time around the Earth, which I mentioned before. Also, you see that the power where we measure is around 1 to 2 minutes. You can see a lot of further things, that the power is, for most of the cases, already at a decent level. So deliberately, we have drawn in here minus 120 dBm RSRP, which is, for the experts, a limit where you could make a call in a terrestrial network. So the power is already at the right level to do so. What you can further see, that you see holes in the temporal coverage. These measurements have been done around March. To our information, that was where Starlink had approximately 70 or 80 satellites for direct to cells in space operating. So for a complete constellation, for a complete timely coverage, you need much more satellites. But what we can see, this is moving right fast. So 5 to 6 months later, today, we know that there are already above 300 satellites of D2C capability in orbit. So it's catching up very quickly, and I think these holes can be filled. So what you need, of course, now to do, you need to do these coverage measurements to prove that the system is working correctly and that the system has all the coverage as planned. Interesting regulatory challenges and questions are, there are many KPIs. I will come back to that a little bit later, but what about regulatory questions? That means spectrum utilization. What do the regulators need to measure when it comes to NTN networks? Monitoring of NTN band blocks. So you need to see if the regulation that you have set up is really fulfilled, and how do you enforce that? And on a higher level, you may think and need to consider roaming issues with terrestrial and satellite networks. So what is the connection now to ITU-T in that whole thing? In ITU-T in study group 12, we have a very good standardization on the evaluation of performance in fixed and wireless networks. So these addresses regulatory bodies. So we have the ITU-T E.800 series, which deals with all these different types of quality of service measurements. And this offers frameworks and workflows. And also here to mention the PG and Y series as well. And we have dedicated recommendations for the measurement definitions and algorithms, which I give here as example, ITUP 6863, 1204, and so on. So what are the questions that are now coming up? When you do quality of service, quality of experience, performance tests, the principles are applying to NTN networks in the same way, but you may ask different questions. Here are 3 questions that came to our mind. Question 1 is, what are the limitations in telecommunication services when you have an NTN networks, especially in the first phase? You may have a complete different structure of latency in such a network. You may have to do more handovers and so on. So the whole deployment is different, and so is the technical outcome. And what are the relevant quality of service measurements? So we need to see, is that what we have as a tool set sufficient, or do we need to come up with additional measurements? And question 3 is, how can existing recommendations be adapted if we have NTN-specific performance requirements? Especially when it comes to network scoring, for example. NTN, exactly in the first phase, might not be the broadband service that we think of. It's more a small band service. It's more maybe for voice, for emergency call, for getting limited data but reliable, and so on. So maybe this, compared to a terrestrial networks, would compare apple to not apple to apple. So we need to see how we do that. Yeah, technical challenges are there. We have coverage propagation loss, RSRP, that was a measurement that I have showed you before. Doppler shift might be a typical thing that we need to measure because, as said, these satellites are pretty fast, so they have a total different Doppler profile. And the spectrum utilization is another thing that I already mentioned. All these types of measurements can be done with passive equipment. So you just measure the downlink signal, and from there you can draw these conclusions. Other challenges with coverage and again propagation loss, cell reference signal measurements, but also tracking area updates, how handovers are done, how the system is working with large delays, and application testing. In such an NTN network, do my over-the-top services still work correctly? Is even my messaging over WhatsApp or Facebook still in place when the underlying networks has totally different KPIs? This can be done with active testing when you are applying this to smartphones. At this stage, and with these thoughts, I would like to thank you. I'm happy to take any questions. We also have a booth over there where we actually have this type of system where we have done the measurements on display in operation. So if you want to get an idea how big that is, what it can do, how it operates, you're invited to stop by at our booth. And with that, I like to thank for your attention and have a happy ongoing WTSA. Thank you very much.